we need to know how does the ionic radius changes across period 3 elements. So we've got the sodium, magnesium, aluminium, silicon, phosphorus, sulfur, and chlorine in period 3 elements. In order to know which of these elements are going to form the isoelectronic species, so we've got to convert all these atoms and elements into their respective ions. So for sodium with a proton number of 11, so the new electron configuration would be, okay, so you just remove the 3s1, so there will be 1s2, 2s2, 2p6. Okay. For magnesium, it will form Mg2+, so we remove the 3s2. For aluminium, Al3+, so we're going to remove the 3s2 together with 3p1. For the silicon, which gonna form a charge of 4 positive, so we're gonna remove the valence shell of 3s2 and 3p2. So write down all the new electron configuration for these ions. So magnesium to silicon 4+, they all gonna have the same electron configuration, which is 1s2, 2s2, and 2p6. But for the phosphorus to chlorine, so remember that they are non-metals, right? So they're going to form an ion with a negative charge, which is an anion. So phosphorus, the charge is going to be 3 minus, so we're going to add 3 electrons to 3p3. So that would be 1s2, 2s2, 2p6, 3s2, 3p6. I'll just write it down in below. And the same thing goes for sulfur. It has a charge of 2 negatives, so we're going to add 4 plus 2. So this 3p4 going to be 3p6. And for chlorine, we Cl minus, so we're going to add 1 electron to the 3p6. So same is going to form 3p6. So write down all the new electron configuration again. So the question usually asks us, how does the ionic radius changes across period 3? So you have to divide them into 3 points. Okay. So first we're going to compare between the cations, and then the difference in shell between silicon 4+ and phosphorus 3-, and the anions. For the cations, which is from sodium Na+ to Si4+, you need to mention that they 4 are all isoelectronic species with an electron configuration of 1s2, 2s2, 2p6. So what happened first is that the proton number, okay, observe that the proton number increased from 11 to 14. So you must mention first that the proton number increased from sodium atom to silicon atom. Notice that we don't compare the electron in the ion, because all the ions of Na+ to Si4+ gonna have the same proton, right? So you have to compare it, the proton number of the atom. Okay, so from Na to Si. So what's gonna happen to the ZAF? The effective nuclear charge is gonna increase from Na+ to Si4+. So we're gonna start talking about the changes that happen when ion is formed. Hence, the attraction between nucleus and other electrons become stronger. So the ionic side, I'm highlighting the ionic because we are talking about the ion, right? Na+ to Si4+. Okay, so please differentiate between atomic radius, which is for Na to Si, which is in the form of atom, with the ionic radius. Okay, so where we're gonna compare the ion form from Na+ to Si4+. So in your explanation, you should write ionic size. So when Z increase, attraction becomes stronger, so ionic size will decrease from Na plus to Si4 plus. For the difference between Si4 plus and P3 minus, okay, so this is where it's coming from. Let's take a look at the difference between Si4 plus and P3 minus. Okay, remember that we're gonna comparing the ions form, right? So we're gonna highlight this. So what's the difference is that Si4 plus has a valence shell of 2, while the P3 minus has a valence shell of 3. So we're gonna say that the P3 minus, okay, since it has a higher valence shell, so it is bigger than Si4 plus as it is located in period 3. For anions, okay, we're going to highlight these 3 rows because we're going to notice that these 3 has the same electron configuration. So the isoelectronic species is 1s2, 2s2, 2p6, 3s2, 3p. So it has the same explanation with the cations. Okay, because when we are going from phosphorus to chlorine, the proton number increase. Hence, the Z will increase as well. But from the ions, attraction between nucleus and outer electron will become stronger. So the ionic size will decrease from P3 minus to Cl minus. So we're gonna say that for cation and anions, they both have the same explanation except that they are different in their isoelectronic species. So if you are asked to draw the ionic size for cation, the sodium ion will be the largest one, followed by the magnesium will be in smaller size. Okay, so and then finally we're gonna have Si4 plus with the smaller size. But for anions, the P3 minus would be the largest size. The sulfur would has the second smaller size, ionic size. And the smallest one will be our Cl minus. Next is the difference between atomic radii and ionic radii. So this is far as you have known that when cation is formed, okay, for example, we have sodium with this electron configuration, which is gonna form Na plus. So we just remove the 3s1. So in short, it has 3 shell, right? This is the first. This is the second, and this is the third shell. So you just remove the third shell. So what's going to happen to the ion is the size of sodium ion will become smaller. But for the anion, for example, we have chlorine with the valence shell of 3s2, 3p5. Okay. So we've got 1, 2, 3, 4, 5, 6, 7 electron in the valence shell. So what's going to happen is we're going to add 1 electron, which is the red one in here. So when electron is added to the 3p orbital, the electron repulsion will become greater. Just remember class, this is electron, this is electron. So these are all electrons. So when they meet with another electron of the same charge, they will repel each other. So when this electron push this electron and it also push the electron next to it, so the size of Cl minus will become larger. So remember that when you're pushing something to the outside, so then the size will become larger.